So, apparently the meeting with Leggett was a success.
I think so.
Because he's no longer in the way
Uh,
of progress.
Well, I don't know for sure what the deal is. Maybe the Board of Education has the real power here to make the decision. And I think according to the lease, we're talking about Nick's Organic Farm. According to the lease, the Board of Education has the ability to take back the lease if they determine the land is needed for educational purposes. And so maybe Leggett's kicking the can to the board.
So they're the bad guys, and they say no.
The whole lot of them, but interesting that the Board of Education is elected. They have district representatives, and we need to communicate to our district representative as soon as we can. We're going to encourage that emails are sent to our Board of Education representatives about Nick's Farm, how it's going to be lost, and the Board of Education is responsible for this. Once again, it's going to be replaced with the 502nd and the 503rd soccer field in the county. I know, kind of crazy. Yeah, so I think it's the 6th that the Board of Education is going to be meeting about that. We'll be there. We'll be there.
So the Board of Education is leasing land from the county?
No.
They own the land and they're leasing it to the county.
They gave their lease up to the county, correct, so that the county could do these soccer field thing. But they have a clause in the contract that enables the Board of Education to take that lease back if they, and I think if they need it for an elementary school or a middle school. But as you know, Nick is trying to make the argument that we can use his farm as an educational resource. And that's what that Chesapeake Foundation is all about. And it's interesting that what they have in mind is courses being taught from colleges down to elementary schools. And classes will go out to the farm, get a lesson from Nick, and see what the farm's all about. So I kind of like that idea. And Montgomery College can be right in that mix. We can get a continuing education class taught out there, just 20 minutes away. So yeah, we'll should be exciting. See how things turn out going down the line. Good morning. So let me kind of set the context for this chapter that we're working on now. Hey, Austin. We are looking at different ways to test the validity of arguments in propositional logic. And there are 3 particular approaches that they outline in the second half of the chapter. And we've just begun to look at the first one. So these are methods for testing the validity of arguments in propositional logic. The first is the truth table method. And that's where you construct a table that explores the value of the argument based on the different values that the claim variables can have in the argument. And so you explore all the possible values that these claim variables can have and what is going to be the truth value of the argument on that basis. And what you do is you try to look throughout that table to see if there's a line, one case, where the premises are true, but the conclusion is false. And if you find one line like that in your entire truth table, then you can conclude that the argument is invalid. Because an argument cannot have true premises and then have a false conclusion and be true. So if you find one of those lines where the premises are true, the conclusion is false, then you can conclude that that argument is invalid. Now, on the other side, if you look through that truth table and you can't find one line where the premises are both true, or all the premises are true, and the conclusion is false, then you can conclude that the argument is valid. That means that there are no occasions on which the premises of the argument will be true and the conclusion will be false. So this first approach for testing the validity of arguments in propositional logic is to construct this truth table, the whole thing, and look to see if you have one line that'll show that it's invalid. One line where the premises are true and the conclusion is false. So that's the truth table method. The short truth table method is not going to construct that whole truth table. All you're going to try to do with the short truth table method is to construct that one line that proves that the argument is invalid. And you're going to try to create a line where the truth values for the premises are going to be true, and the truth value of the conclusion of the argument is going to be false. Now, if you are incapable of creating a line like that in the short truth table, then the argument must be valid. And so the short truth table is going to take a shortcut. It's going to simply try to create that one line that proves that the argument is invalid. And if you can't create that, then you can conclude that the argument is valid. So the truth table method, the short truth table method, and then the method of deduction. This is the fun one. This is the Sherlock Holmes approach. On this approach, you take the premises of the argument and you see if you can generate the conclusion using established patterns of argument that are indeed valid. And we'll talk about those established patterns of argument. And so you look at the premises and then you say, oh, using modus tollens we can get this, and then using modus ponens you can get that, and then we get the conclusion. So you take legitimate steps in the argument from the premises to the conclusion using established patterns of argument which will name and will have rules associated with them. So this is the fun approach where you take the argument and you look at the premises and you can see if you can prove the conclusion based on the premises using the various rules that we're going to talk about. So those are the three methods for testing the validity of arguments in propositional logic. And we took a look at the truth table method. And here you see a truth table for an argument that is not valid. This is not valid. Now, how do we know it's not valid? Well, because we have an occasion where both these are true and this is false. Both these are true and this is false. Where's that line?
First one.
What's that?
Isn't it the first one?
Third.
Line 3, right here.
Oh.
So this is true, that is true, but this is false. So this line right here proves that this argument is not valid. It's not valid. Now this is the full truth table approach. If we were using the short truth table method, all we would do is construct this one line and we'd show that it's false. But on the full truth table method, you lay out all the values, and here the idea is you're just imposing values on P and Q here. But what you need to do is to make sure that you cover all the possibilities. And at one part of the chapter it tells you how you do that. If you have two variables, well then you can make both true, both false, and on this one you alternate them. And there's a technique to make sure that you explore all the values. But then you translate these into here. So if P is true, not P is going to be false. La-di-da, that's the way it goes. So you take those truth values, translate them through, and you see if you can construct one line that proves that it is not valid. And in this case, it does have that line. Understand the truth table method for the most part. I think we had one other example we looked at here. We will have a large mass of Arctic air, unless the jet stream moves south. There is no chance of the jet stream moving south, so you can bet we will be getting Arctic air. Now, this argument is valid. Consequently, we will not be able to construct a line in the truth table where these premises are true and this is false. So look at the two occasions where this is false, and we need to try to find a case where both of the premises are true. And here, not J is true on this occasion, but A and J is going to be false. So if this were true, we would have an argument that's not valid. But now we have an argument that's valid because there are no occasions on which the premises are true and the conclusion is false. You think you can do this? Ain't rocket science. It's logical.
So the last one is not J.
Correct.
And what's AVJ?
That's a disjunction. It's A or J.
A or J.
A or J. And when is A or J false? When is a disjunction false?
When A and J both are false?
Correct. Very good. Very good. Very good. You're paying attention, Matthew. All right, so let's move on to take a look at the short truth table method. This is the method for slackers, so I guess it's all interest to all of you. If you don't want to construct the entire truth table, if you want to save some time, in order to test the validity of an argument, what you can do is simply look to create that one line in the truth table that will demonstrate that the argument is invalid. So we want to look to see whether there's one row in the truth table, at least one, where the premises are true and the conclusion is false. The easiest systematic way to test the validity of truth functional arguments. It's the easiest because you cut right to the chase, essentially. Now, let's take a look at this. The conclusion is going to be false if P and R are false. Now, the question is, can we make both of the premises true? And let's take a look at, here we've done it. Oh my goodness, it's my own phone. I apologize. And I got it on video too. Sorry about that. So here, once again, what we're trying to do is create one line in the truth table that will make these true and this false. And they think they've done it right here. And so let's explore what's going on here. If we make P false, Q true, and R false, it shows that we can construct a line where the argument is invalid, where the premises are in fact true and the conclusion is in fact false. So let's trace this through. If P is false and Q is true, what is P implies Q? Huh?
Invalid.
Nope.
It's false, so it's invalid.
No. What does it take in order for P implies Q to be false? What does it take for a conditional to be false? We talked about this last time. I know it's hard to remember. In order for a conditional to be false, this one in particular, P implies Q, in order for that to be false, P must be true and Q must be false. If we begin with P being false, well, it's not a problem. So, if P is false and Q is true, then this is true. So the idea is we're trying to construct a case where these are going to be true and this is false. And they've done it using these truth values right here. So the idea is that if we make P false, Q true, the top one is going to be true. Now, let's make Q is going to be true and R is going to be false. What's this going to be? Well, if Q is true, then not Q is going to be false. And R is going to be false. And if this is false and this is false in an implication, that's going to be true. So on these values, both of the premises are going to be true. Can you see that? On these values right here, both of the premises are going to be true. But now let's look at the conclusion. And let's see if the conclusion is going to be false. Well, if P is false, not P is going to be true. So that's going to be true. And R is going to be false. Well, that's exactly when a conditional is false, when you have the antecedent. The first component is true, and the second component is false. Consequently, with these truth values, the premises are true, the conclusion is false. Therefore, there is one line of the truth table where you can show that the argument is invalid. And the advantage of the short truth table method is that you can prove an argument is invalid with this instead of the whole truth table. So when you're trying to do this, what you're going to try to do is look for values that will make the premises true and the conclusion false. And if you can't find those values, then you have a valid argument. Then you have a valid argument.
So the both are premises. That's the Q hat towards the R. It's a premise too.
P implies Q is the first premise.
Okay, and then?
And not Q implies R is the second premise.
Okay, so it gives a conclusion. So you are looking for the values of the two premises.
Well, you're looking for values of the claim variables that will make the premise true and the conclusion false. And just to be specific, the premise is the whole thing. It's the conditional. The claim variable is the P and the Q.
And the Q hat and the R.
What's that?
And the Q hat below it and the R. Because the Q hat below it and the R is another premise too.
Correct.
Okay.
Correct. Not Q implies R, that's another premise.
Okay, so you are checking both to get to the conclusion.
Correct. In order to use the short truth table method to test the validity of an argument, what you're going to try to do is find values for each claim variable that make both of these premises true and that conclusion false. And when we speak about the premises, what we're talking about is this whole line here. P implies Q. That's one premise. Not Q implies R. That's the second premise. Any other questions? Let's try one more. So here it's P or Q implies R. Second premise is S implies Q. The conclusion is S implies R. S must be true if R must be false for the conclusion to be false. So in order to make the second premise true, when S is true, Q must be true. But there is no way to make the first premise true, therefore this argument is going to be valid. Now, we've made an effort here to try to make, that one line where the argument will be invalid. And see, the idea is the first thing you look at is for what makes the conclusion false. So in order to construct that line in the truth table that shows that the argument is invalid, you need to have a line that makes the premises true and the conclusion false. So as you're building up that line, the first thing you can look at is the conclusion. What does it take to make the conclusion false here? What kind of truth values does it take to make the conclusion false? Well, when is a conditional false? We talked about that just earlier. It's only false if the antecedent is true and the conclusion is false. All right, so in order to have truth values that make this argument invalid, we're going to have truth values that make this claim right here false. In order for that claim to be false, S must be true. You see that? S must be true. So the short truth table method is going to begin with the conclusion, and it's going to adopt truth values that will make the conclusion false. And then you carry those truth values through, and you see if you can find a set of truth values that will not only make the conclusion false, but it will make the premises true. So we need S to be false and R to be true in order for the conclusion to be false. Excuse me. S must be true and R must be false in order for the conclusion to be false. So what we start with are S being true, R being false. So now you can understand the steps in the procedure of setting up the short truth table method. The first thing you do is look for those truth values that are going to make your conclusion false. And here, we need to make S true, and we need to make R false. Now, in order to make the second premise, S implies Q, we need to make that true. In order to make the second premise true, when S is true, because we've already established S being true here, well, Q must be true in order to make that line true. So first we make R and S these values here, and then in order to make this second premise true, we're going to give a true value to Q. So now our only challenge is making this premise here, the whole line, how do we make that true when we have these values for the claimed variables? And so we've already established that Q is going to be true. Now, when is a disjunction false, Matthew?
When the antecedent is true?
No, you had it right just 5 minutes ago. It's only
Oh,
going
when they're both false?
Correct.
Oh, okay.
Right. So this is going to be true unless both are false. Well, right now we know that Q is true. All right? So this is going to be true. Now here's the problem. R is false. We've already established that R is false, and we needed to do that in order to make the conclusion false. So we can't help it. First, we know that Q is true, regardless of the value of P. So, and we know that this disjunct is only going to be false if both of them are false. Well, we know that one is true, so that we know that this disjunct is going to have to be true. And we know that R is false, and we know a conditional is going to be false if the antecedent is true and the consequent is false. Therefore, there is no way to construct a line in the truth table that will make the premises true while the conclusion is false. Therefore, the argument is valid.
Then R has to be true.
What's that?
R has to be true.
Why?
For the conclusion to be true.
No. Let me explain. We're trying to set it up so that the conclusion is false and the premises are true. So what we're trying to do is set up values for these plain variables that will make the premises true and the conclusion false. So the first thing we did is looked at what values do we need here to make this false. All right? So what values do we need to make S and R to make this false? An implication, you know?
Yeah, we say that R has to be false and S has to be true.
Right.
And that the conclusion is false.
Correct.
Now, if the two premises are true, the conclusion cannot be false. If the two premises are true.
You're right. If this was a, say that if the premises are true, the conclusion must be true?
Yes.
Correct, because this is a valid argument.
Mm-hmm.
Now, What we were trying to do is prove that it's invalid.
When it's valid.
Correct. And that's why we were incapable of doing it. So what we tried to do, Maddow, was create one line in the truth table where all the values would lead for this argument to be invalid. We were unable to do that right here. So you're right. This has to be the valid argument. Has to be a valid argument. So just to summarize then, the short truth table method is going to give you a shortcut, whereas the full truth table is going to have you create values for all of the claim variables and to explore what all those values can possibly be. In the short truth table method, all you're going to do is focus on creating that one line in the truth table that makes the argument invalid. You're trying to prove that it's invalid. And when we fail to prove that it's invalid, we conclude that it is in fact valid. Now, the way we go about constructing that line in the truth table that demonstrates that the argument is invalid is we first look at the conclusion and we see what kind of values we need in order to make the conclusion false. Because in order to prove that this argument is invalid, we need to show that the premises can be true and the conclusion is false. So first we look at the truth values. What is going to make the conclusion false? And here's where we say that S must be true, R must be false. Second thing we do is we see what truth values do we need here in order to make this premise true. And then the final step is to see what truth values do we need to make that first premise true as well. And if you can make it each step and show that there is a line in the truth table that makes both premises true, the conclusion false, then you know that the argument is invalid. But as Maddow pointed out, if we're incapable of proving that the argument is invalid, then we can conclude that it's in fact valid. Questions, comments? Yes, ma'am.
So if you had to ask like a question for us to use, I don't know if you had to ask like a question, how would the question be if we had to use a method like this?
I have not constructed any as yet, but I think that what I would do is give you some kind of argument like this and ask for you to create a truth table like that that proves that it's invalid or demonstrates that it is in fact valid. So I might give you this and ask for you to construct that if possible.
So we'll have an option between the kind of table we make?
I'm not sure. I haven't constructed the test as yet, but I might ask you to use the full truth table method for one, the short truth table method for another.
When is the test?
The final exam we're talking about. Vivian?
Yeah, so we are supposed to know how to control the full, how to construct the full truth table.
What's that?
We should know how to construct the full truth table.
Correct. That was the first method that we talked about earlier. So the full truth table method is where you construct this whole thing. And you look for that one line in the truth table that makes the premises true and the conclusion false. That's the full truth table method. The short truth table method is where you only construct that one line right here that proves that it's invalid. Any other questions? I don't know whether I want to pour any more in. There may be more than one way for a complex argument to be invalid. This is a good point. When you use the short truth table method, you're only going to find one way to make that argument invalid, one line or one set of values. The reality is that there may be more than one way for an argument to be invalid. We need to recognize that. Now, let's briefly talk about this third approach to testing the validity of arguments, because actually it is kind of the funnest way to deduce the conclusion from premises. Deduction, the method of deduction. This is a method of testing the validity of arguments that leads us to attempt to derive the conclusion from the premises by way of a series of valid argument patterns. And so you look at these premises and you see, oh, based on modus ponens, I can deduce this, modus tollens, I can do this, and then that leads me to the conclusion, therefore I know the conclusion is true. So what you need to learn in order to use the deductive method is the valid argument patterns that can lead you from the premises to the conclusions. And there's a couple of groups of rules here. Group 1 refers to elementary valid argument patterns. Group 2 is going to refer to truth functional equivalencies. And these are going to be slightly different as we see. So first, we're looking at Group 1 rules, elementary valid argument patterns. And the first one is modus ponens. This should be familiar to you. It talks about the conditional argument, and it's really simple. The idea is that if you have a conditional, P implies Q, and you have the antecedent, you know that P is true. Well, you know that Q is true as well. And if you have this pattern of argument, if you have a conditional and you have the antecedent, then you can deduce the consequent. Anytime you find that pattern in the premises, you can deduce a Q. So if we had premises that had these were two premises in an argument, we could deduce Q from both of them, and we can put modus ponens as the way we did that. And I'll give you an example here in a sec. If the premises include a conditional and the antecedent, then the consequent follows by modus ponens. This is what we're talking about. Let's say you have these two lines in the premises of an argument. All right, you have this disjunct implies Q, and then you have that disjunct. Well, using modus ponens, you can argue that these two will imply Q by modus ponens. So if you have this, you get that. Here you have this, and you get that. Now the idea is in a larger argument, you're going to use a couple rules of deduction to lead you to the conclusion eventually. But this is a simple one, modus ponens. How about another one? Modus tollens. If the premises include a conditional and the negation of the consequent, the negation of the antecedent follows by modus tollens. So if you have P implies Q, you have not Q, that will imply not P. Now once again, if you find these two in an argument as premises, then using modus tollens, you can deduce P using that rule. Now here is an example of an argument and the way we would draw it up if we were using the deductive method in order to try to determine whether the argument is valid or not. And just to explain what's going on here, these are the three premises, and this is the conclusion, not P and Q. This is my version of the conclusion science, not actually exact to what they have in the book, but that's what I mean by this. This is the conclusion right here. So here, the game is, using the deductive method, is to take these premises and using the valid argument patterns, deduce from these premises that conclusion. That conclusion. Let's see how it works, ladies and gentlemen. First, we can get not R. And, you know, before, how do we get not R? Well, it's pretty easy.
S is not R.
Yeah, right there. So what you have right there is modus ponens. If you have a conditional and you have the antecedent, then you know that you can get the consequent. So using premises 2 and 3 and modus ponens, we can get not R here. See that, Vivian? Not quite. So let's go back. Here are the premises of the argument. All right? And we know that if we have P implies Q and we have P, then we get Q. Well, let's take a look at the argument here. We have S implies not R, and we have S. Well, we know if we have this, that we can have not R modus ponens. All right, what's the next line that we can get here? Does anybody know the next step to take? Yes, sir. Yeah.
Do we have not P and not Q? Since we have not R, wouldn't number the first one, don't P and Q have to both be false?
I think you're right. Using modus tollens.
Right.
Man's paying attention. And if we're paying attention, we know that this is the conclusion. So what we've done here is we've deduced the conclusion from the premises using these valid argument patterns. And when we do that, we know that we have a valid argument. We know that we have a valid argument. And the reason this is the Sherlock Holmes approach is because we use these valid argument patterns to deduce conclusions. Much like Sherlock Holmes, you know, they have a third sequel of, they just make these, you want a series of movies now, you just want to get into one. Mission Impossible or something like that. You just make
Mission
movies.
Impossible 7 coming out?
Yeah. It's like
And the
great.
stakes are higher. Again.
Of course, absolutely. But
This time they're not just going rogue, but they're the enemy number one.
what, are they making it like a Jason Bourne thing where they're turning it against their own supporters?
Right.
That
I
would
think
be-
they already did that, but now like everyone's after them.
That was in 5.
Right.
Mission Impossible 5.
Right.
Tom Cruise needs to make more movies.
So and this time it's when they're trying to save Scientology here.
Oh no! That was a good joke, anyway. Tom Cruise is a Scientologist. All right, you know what? That's about as far as I want to take it with these new deductive method, because we only got this one last class, and I wanted to give you a flavor for each of the approaches that we take to testing the validity of arguments in propositional logic. And there are 3 approaches to take. You should be familiar with all 3 of them. The full truth table method, where you lay out all of the possible truth values for all of the claim variables, and you try to find if there is one line in that truth table that will make the premises true and the conclusion false. And if you have that line, you know that the argument is invalid. If you don't have that line, you know that the argument is valid. Then you have the short truth table method that is going to be much more efficient. You're not going to create the entire truth table. All you're going to do is try to create that one line in the truth table that makes the premises true and the conclusion false. And when you take that approach, you're first going to take the truth values that make the conclusion false, and then you're going to try to add values that will make the premises true. And then finally, the third approach to testing the validity of arguments in propositional logic is this method of deduction. And that's where you're going to list the premises, and then you're going to try to deduce from the premises the conclusion using established argument patterns in Group 1 and Group 2. Questions? Comments? Dumped a lot of material on you, I know. Yes, ma'am.
So for chapter 9, we're just going up to,
Yes, right here.
okay.
I won't take it any farther.
Okay.
Won't test you on any material after this page.
You haven't posted these last thing yet. The last record, the last classes, you haven't posted in the link.
The PowerPoint,
No,
the video,
the video.
you're right. You're right. I need to do that. I will. In fact, in preparation for next week and the final review week, I'll have all of the videos up for these classes so that you can use those videos to help prepare.
And
Have you actually looked at some of those videos?
of course,
No kidding. Have you actually?
yeah,
God bless
especially
you.
on the Pharisees and
Well, I'm glad that they help out. I'm teaching an online class right now, and so that was my first thinking, is to help the online class, but for students in the on-campus class, it can be helpful as well.
that's why you are in the class for the second
Yeah.
And
Yeah. In fact, I want to keep doing this next semester because I'm hoping to improve my teaching ability as I go along, but also to get accustomed to sharing this resource with students, not only in the online classes, but in the on-campus class. You know, you miss a few classes, stuff like that, easy to catch up.
And about the questions and answers, I didn't say.
The questions and the answers.
Yeah, I thought you said you post it on. I didn't see them in. About the last quiz. I think.
I can show you where those are. And